Okay, great. Now, the other day we started talking about, we were talking about the, as a recap, as a summary of, what we have learned over the last 12 weeks in the semester. Some rule of thumbs, some principles, some practical tips, how we can use the techniques we have learned over the semester to come up with a good software design. So, at the end of the day, we said there are 11 of these rule of thumbs or principles, and I think we covered till probably here, if I'm not mistaken. All right. So, just to very quickly recap, we talked about divide and conquer. That you should be using your architectural styles and your your packages and concept of classes to come up, and rather than writing everything in one big file, try to divide them into different units of smaller subsystems, and then you basically design them accordingly. Now the next one was increase cohesion, that you are always interested in increasing the cohesion of your system. And on the other hand, at the same time, you are also interested in reducing the coupling of your application, of your subsystems, classes, packages. You try to keep the level of abstraction as high as possible. This means, use classes, use the concept of interfaces, use packages, use, fewer number of parameters in your method signature, so on and so forth. And they go hand in hand. And this is where we stopped the other day. Is basically, try to increase the reusability of the piece of the code that you are developing, and also at the same time try to reuse existing designs and codes where possible to help you achieve the target of reducing the cost and increasing the time of development, and shortening the time of development, and probably increase the quality of your system because you have tested them thoroughly. So with this, let's jump straight to the remaining 5 rule of thumbs or design principles, which are important for us to keep in our mind when we are designing our applications. And then inshallah, in the second half of the lecture, we'll move on to the next topic, which is the software refactoring. Everybody is comfortable before I move to these number 7 design principle?
Yes.
Okay, good. Thank you. Okay, so we have to also, at the same time, when we're designing our applications, we have to anticipate change, because of course we all know that systems change, and they go through different maintenance phases, and new functionalities need to be added, and so on and so forth. So we have to, when we are designing, we have to keep flexibility in our mind as well. And as we know, the principles we have learned, if you recall the solid principles we learned earlier in the semester, the design patterns, even the architectural concepts, they help us design for flexibility anyway, because systems are more modular, they are cohesive, less coupling, it's easy for you to change, because when the changes will come, if you have less coupling, more cohesion, it will be a bit easy for you to go on and make systems more flexible and change accordingly. Of course, we also, as we learned to use the concept of interfaces, was very useful in creating abstractions, and also, segregating them into smaller units. Again, it helps flexibility. We all also know that, it's not a good idea to hard code stuff, right? You want to be as general as possible, and, as a result, you need to leave all the options open so that you can go on and change it accordingly, change a part of your system accordingly. And, of course, you try to make sure that you write more reusable code and make code reusable. Again, the way you do it is making systems more flexible and making them more general. So this is, something we always try to achieve, and the techniques you guys already know by now are gonna help you directly or indirectly design for flexibility. Now, we also have to anticipate obsolescence, which means basically, you might have to plan for changes in the technology or the environments, so the software will continue to run or can easily be changed. Again, this is something very, very crucial for us as designers, that and probably you might have been seeing that in this phase of the project, you have to look at the technology and you have to make a comment on it, that what kind of technology you're going to use for such a system, and what kind of hardware you will need. And this is all part of your design decisions, because these technologies you are using, you first of all have to select the one which is the most appropriate one, which will come as the next principle anyway. But you have to think about that these technologies can be outdated. They will retire at a certain stage. So you need to understand that how I'm going to be able to move from one version of the technology to the next version of the technology easily. And that's all done if you follow the rules you have learned so far, the principles you have learned, the techniques you have learned, which are, abstractions and encapsulations, the basic principles, the solid principles, the architectural principles, the design pattern principles. If you use them, it will help and facilitate these changes in the technologies. Of course, another rule of thumb here is that we should not be trying to develop applications, especially the critical applications, on some technologies which are just in their beta versions, for example, right? For example, last year or maybe a year before, I had a team in my senior design project, and they were developing a system using Flutter. And Flutter at that time, how many of you are familiar with Flutter? Or have you heard about Flutter?
Yes.
Most of us know Flutter now.
Mm.
Yes.
Good.
It's
So a
become
couple of you.
famous.
Yes, so famous. So a couple of years ago, it was in the beta version still, and they started using Flutter. But again, they were student senior design project for housing systems. So they banked on it because they want to learn. They wanted to learn the technology. But but they had so many bugs in it, and not their own bugs, but because the Flutter itself was in beta version, so there were so many technical issues in it, and hence, if you're developing out there in the market some projects, you should be avoiding use of early release of technologies unless they are stable and unless you have enough documentation for it. And again, this is something you have to keep in your mind as designers. And of course, we should be always trying to use, libraries which are more generic. So you should be trying to avoid certain libraries, APIs that are specific for a certain platform. Of course, you cannot avoid this naturally all the time, but you should try to minimize it. Don't try to use APIs which are, you know, um, which are only specific for certain contexts, only works on a certain environment, and then you're stuck there. You cannot, what if those APIs are not supported anymore? What if those APIs are not available anymore? The company goes out of business who created those APIs. So you have to really think about all of this stuff, which is also part of your design decision, and they play a big role there. So of course, and as it goes, you should not be using any undocumented features or little used features of those libraries, because again, if you're developing, for example, a banking system and you start using some of these features which are not documented, some of these features which are in beta release, you don't know what kind of bugs they're introducing. If you're stuck somewhere, you will have no help to fall back on. And on all of this stuff is very, very important. And as a rule of thumb, you should be going for more stable technologies, for your applications. And of course, avoid using software or special hardware from the companies that are less likely to provide long-term support. This is also very important. And sometimes it is actually very, very critical for larger organizations, that they don't want to go on and bank on a certain hardware which is only developed by one company, and it's such a small company that it's a startup company, so maybe you don't know how stable they are, how how mature they are, how they're going to provide them the long-term support for their hardware. So all of these things are important. Of course, it varies from one case to another and depends on the project you're developing. That sometimes you are willing to take a risk with a startup, a hardware company, some for example, but generally like companies like Aramco or banks or airlines, probably, you know, you go to them and don't be surprised that they might be using certain old hardware or they might be using certain old software still. And the reason is they don't want to use the new ones which are still not stable. They don't want to move to the new one which are not yet, they cannot have a confidence that this will be good support for it. There will be good hardware technical support for it and so on and so forth. And of course, use programming languages or technologies that are supported by multi-vendors. It's always helpful. You will have more resources to fall back on. You will have more. Yeah, it will be easy for you to recruit people with or manpower with those programming language skills and so on and so forth. So, for example, if you're using Java, there's high probability, or using Python or C Sharp, you have high probability that a lot of people will be familiar with it. But if you're using a certain new programming language, which only few of people in the market knows, then you're really cornering yourself. And you don't want to corner yourself, from the uh, design perspective. Everybody's on board with me on this point.
Yes.
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 Great. So this leads us to the ninth rule of thumb, which is the design for portability. You don't want to design systems using older technologies which are not stable. Sorry, you don't want to use the technologies which are not stable, or things which are very specific, or companies which are such a small company. You want to avoid them to begin with. Similarly, you want to design for portability. That you want your system to run on as many platforms as possible. And this is so true nowadays with mobile applications, for example, right? You have Android, you have iOS, you have Windows platform, and so on and so forth. And then you go to televisions, and you have different kind of operating systems with Android TV to Samsung has its own, and LG has its own, and Philips has its own, and so on and so forth. So if you're developing certain systems, you want your systems to run on multiple platforms as much as possible. So now, of course, uh, when we say avoid use of facilities that are specific to one particular environment, this is, we have to take this with a pinch of salt here, is that uh, we have to, as a designer, think that what's the most appropriate way of developing such an application. So you may, according to your context of the application, you might decide to go on and develop using Flutter because it helps you develop applications for both Android and iOS, or React Native. But doesn't mean that every time you have to go with this option, because you might have, you have to think about what are the things I'm looking for, whether they are better supported, they are better provided with the documentation, maybe in native Swift or Android Studio, for example, right? So you are always interested in portability, but you have to think that how you achieve portability. You don't have to go with all the time tools which gives you in one go multiple platform applications, because they have their own limitations. Okay. So you have to carefully think about this point. So for example, you might have a library with an API which is only works on Windows, and no, if this is the only option you have no other choice to do anything else. But as a design, the whole idea here is that you think about all the different possibilities. Uh, the possibilities has been, you have to explore the possibilities. Uh, is everybody clear on this point as well?
Yes.
Okay, great. Now, testing is also very, very important. And inshallah, next semester, I believe most of you guys will be taking the testing course. Designed for testing. Testing is heavily impacted by your design. And if you come up with a design which is more modular in nature, so you have designs which has more better structure packages, you're using the packages, you're using the subsystem concepts, you're using the classes, you're using the methods and well-defined methods, and you're applying the solid principles of them and so on and so forth, it will be very easier, a lot easier to test uh, than a system which is very complicatedly designed and it has so many dependencies and coupling between them. So testing actually depends a lot on how you have written your code, which basically depends on how you have designed it. And as a designer, you should try your best to design your systems. Again, you don't have to go outside and do any rocket science here. Basically, you follow the principles you know. And as a result, as a byproduct, you will get a system which is probably easy to test. And and then again in testing you will learn that it's not an easy task anyway, and that's why we try to sometimes automate them. And for automated systems to work and automated testing to work, again these new systems need to be more modular and more cohesive and less coupling, because then it will be easier to automatically test these applications. So basically, you should be also in the moment you make your system more modular, it will help you in testing because, for example, you want to test only because you do testing, you will learn this later as that, that you do testing at different levels and you do testing at unit level and integration level and component and system level. So you have to, make your system in such a way that, you can test these classes, these packages individually, and then you can test them working together and so on and so forth. And again, if you are not careful with your designs, you will suffer a lot at testing. So for example, sometimes programmers, testers, they use, main methods in each classes to go on and test their different methods individually, and then they use it to test integration and then use it to test the whole system. So it's very important that, you keep testing at the back of your mind when you're designing. And this is, by the way, is achieved automatically as a byproduct the moment you follow the principles you have learned in the semester, the basic abstraction encapsulation principles, and then basically the 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 solid principles and the design patterns. Everybody's comfortable with this?
Yes.
Yes.
Great. And this leads us to the last one, which is design defensively. Now, this is something we also talked earlier in the semester when we talked about the concepts of correctness, flexibility, and usability, right? Or robustness, right? We talked about the correctness, robustness, and usability concept. So we have to think about, as designers, design defensively basically means that never trust that how others will use your component. In other words, you should anticipate inappropriate interactions with your system. And you have to understand that sometimes the developers, the users will try to use your piece of code you have written, or a package you have written, or a component you have written, and they may not be using in the way you thought about that they will use it. So you have to handle cases where your code might need to or is passed on a wrong parameter, or is passed on, or is called from a wrong sequence, and you should not, and you don't want your system to be in a state where it's stuck. You always want your system to show a robustness, in a sense that it shows a correct error message or some kind of a message to the user that something went wrong. And then not only that, it should come back to a more stable state as well, right? And this is something as a designer sometimes we overlook. We don't pay a lot of attention to this part, but this is very, very critical for us to do. That you want your systems to be able to recover to a more stable state, because you cannot always expect that the person who is calling your class or a person who is using your method will always design the way you thought. Now, of course, there is a technique to it, which is that you specify your preconditions. you specify your post conditions, you clearly indicate your conditions that, if you want to use this piece of code, this could be a method, this could be a class. The precondition is that, you pass these variables with this data types, for example, right? Or the array should be sorted or whatever, right? So you have to specify this, and this of course helps you in your designing the system, which is more robust, definitely. Of course, the only thing is we have not yet covered this part yet, this specification part. We have not covered this in the semester yet, or the construction part. Now, inshallah, we will be talking about this part next week, inshallah. So we'll be covering, and hopefully this will, kind of complete the whole discussion on the design. All right. All good?
Yes.
Yes.
Great. Now, so in a nutshell, if you look at these, the ones we covered today, so basically, you try your best to follow these 11 rules to come up with design of your applications. Again, these 11 rules are your summary of the things we have learned. So basically, you can keep in your mind these 11 rules, and then you use the techniques you have learned over the semester, and as a byproduct, you will get them anyway. But you have to just keep in your mind that, I'm designing my system, for example, I have to think about its robustness. And for example, I'm thinking about designing my system. I have to think about its portability, if that is the case, or how I can make my system more modular so that it becomes easy for testing, and so on and so forth. So techniques for making some of these good design decisions, naturally, you know all of them from a technical perspective, but just kind of, summarizes the process for you, that you have to go on and prioritize your objectives. And you have to think about the alternatives. Now, this is something I have said again and again in the semester. And this is something I want it to be inbuilt into you, that you have to think about alternatives. As a designer, you cannot come up with one's design and say that this is a good design. No, there is no basis for you to say that this is a good design unless you have some alternatives. This is why I encourage you guys in the project phase 1 to look for different architectural styles. And this will be the case as you move along to your detailed designs, and you have to think about, how I can better restructure this system. Maybe I can use interface, maybe I can use abstract class, or maybe I can use certain design pattern to better restructure it. So unless you think about alternatives, there is no way you can be confident that I have come up with a good design. Of course, with experience, you may be able to do this quicker. But this is my message from day one to you guys. As a designer, you have to think for alternatives. And it's not a rocket science again. You have to just list your alternatives for your design decisions. You think about, oh, for this part, how I can do it. There are 2-3 options I have in my mind. You look for their advantages very quickly and see this design pattern, this is what I will get. Maybe I'll have to compromise on performance or so on and so forth. So you do that kind of analysis very quickly. You also understand that if I use a certain alternative, it may prevent me from meeting one of my objectives, since I cannot consider this at all, right? And then you look for alternatives, which basically helps you better select or meet your objectives, and eventually you just go on and select that one, right? Everybody is comfortable with this?
Yes.
Yes.
Right, and this is my message from day one, and I hope I'm able to convey it to you guys, that as a designer, you have to think about alternatives for design decisions at every stage. Now, of course, as I said, the architectures I have, this is where the role of the software architect comes in. They play a big role there, because with their experience, they're able to help decide that these are my alternatives and these are my design decisions. Uh, But this I want this to be a part of your culture as a software engineer. I want this to be part of your design as this culture as a designer. That you always think about alternatives, and you have some alternatives in front of you. You look at their pros and cons. You look at that, whether they will help you restrict in achieving one of your objectives, and then you select the best one which you believe is going to help you achieve your target. Again, this is simple 4 steps. With experience, you will be doing this very quickly. Probably in the beginning, I recommend you to write it down. Again, later down the track in your careers, probably writing them down will always help. But maybe you will be able to do it quicker. But you still need to do this if you want to become a good designer, you want to become a good software engineer, because like any engineering discipline, unless you think about alternatives, there is no way for you to make a claim that this is the best solution for this problem given my technologies and given my platforms and so on and so forth. And this leads me to the last step, which is basically, sometimes you will have to adjust your priorities for many reasons. Now, let me share you an example here. A couple of years ago, I was, uh, doing the supervision of the senior design project, and one of my teams, a couple of years ago, they were developing this. It was actually not a couple of, maybe 3-4 years ago. They were developing an attendance system, right? Now, as part of the attendance system, the main idea they had at that time was that we will have, because now mobile devices 4 or 5 years ago started having these fingerprint scanners. So they said that we're going to use fingerprint scanners to do the attendance. Now, when it came to technology, and then they explored the technology, I forgot which one, but they realized that either this and the iOS, the Swift was not supporting the fingerprint. They were not having the API for the fingerprint scanning publicly, or the Android Studio didn't have that. Uh, Probably it was the Swift iOS did not have the API, public API for fingerprint scanning at that stage. So, and it was only available in Android. So, you have to sometimes go on and look at your priorities, and you might have to adjust accordingly, right? So maybe you have to say, well, I might be only be able to release this on an Android mobile phone, or maybe I have to come up with a new solution for this problem, right? So this is something which will happen. You might have to change your priorities, but this is a natural process, and with time, with experience, this will become more and more faster for you. So let's look at a very simple hypothetical example here, right? That, let's say you imagine developing a system and you have a set of requirements, especially non-functional requirements, and yet they have certain priorities for your system that you want security, and you're looking for a certain kind of a security. For example, you're saying that encryption must not be breakable within 100 hours, and using a certain CPU and using certain techniques. And you might have, from a maintenance perspective, you say, oh well, I don't have any specific objective, I'm fine with that. From a CPU efficiency, I want the CPU to be working within certain time frame, within a certain unit. I want it to be fast. I don't want to overwhelm the network bandwidth, so I must not be requiring more than a certain, say, 8 KB of data transmission per transmission section. Memory use, I want certain RAM size to be available, and I want the system to work on different platforms. So if you have such kind of requirements, non-functional requirements, some kind of objectives you want to achieve in your system, again, the message here is prioritize them, look at them, compare them, and again, you don't have to do a lot of rocket science here. You can use a simple table as this, a simple comparison table like this. And you can say that, okay, these are my objectives I'm trying to achieve as part of my design. These are my algorithms, for example, which can help me achieve it. And then you can basically just give them high, lows, and mediums. And then you realize that, for example, in this case, security is very important for you. And if you select algorithm E, it will not even give you that security at all, right? So hence, very quickly, doing this exercise, you are able to decide that I should not be wasting my time and selecting algorithm E anyway, because it does not help me achieve my target. Is this message clear, right? That don't have to do a lot of complicated things. They're as simple as this will serve the purpose.
Yes, it's clear.
Cool. Of course, deciding on how that, for algorithm C, security is high, you need to understand algorithm C, isn't it?
Yes, of course.
Yes.
Of course. So hence, as a designer, of course, as I said, as a designer, as you will become more and more mature, you will become more and more, strong in your programming skills, and you have more exposure to different technologies. Of course, it will be easier for you to make these decisions. But first, we have to build this culture that I have to think about these decisions, and B, with experience, you will learn that, algorithm C is high or algorithm E does not do it, because you have a clear understanding of algorithm E and you have a clear understanding of algorithm C. But something like this is a good, simple mechanism. Do this evaluation, look for alternatives, and then select the one which is the most appropriate one for your application. So in a nutshell, we are always interested in coming with a good designs. And the reason we are trying to come up with a good design is because we are always interested in increasing the profits, reducing the cost, increasing the revenue. We also want to make sure that our systems are correct, means they conform to the requirements. We want to increase the speed of development. We want to increase the quality. And as a result, if you want to have a good design, I just encourage you guys to keep these 11 rules, basic rules in the back of your mind. You know the techniques. You know the techniques of the basic design techniques like abstraction and encapsulation. You know the architectural styles. You guys now know the solid principles. You guys know the design patterns. So basically, if you use these techniques as something in your back of your mind, and you use and apply and use the select and write appropriate techniques from here, you will end up with, inshallah, good design. Of course, there are one or two things which are like refactoring and construction, which I said earlier in the lecture today. Inshallah, we will be covering this in the next 2 weeks. But you have the basics now available to you. Everybody is comfortable with this?
Yes.
Good.
Yes.
Alhamdulillah. Alhamdulillah. So this is, see, we are almost in the week 12 now, but today we're finishing week 12, subhanAllah. So we're towards the end of the semester, and this is the whole idea. We started, see where we started, and this is the summary of what I want you guys to do. Hopefully this will help you clarify, why I learned these different techniques. You learn them because you will be able to use them to achieve your good design goals. Okay, so with this, let me stop this one, and then we can move on to the next topic for today. Any questions on this, guys? All good, right?
Yes.
I
It
think
was
it's
like
clear.
a summary.
It was a summary, exactly, as I said. Okay, so let me stop this one and move on to the next one then. Okay. again, probably how to do this. Are you able to see the screen?
Yes.
Yes.
Okay. Now I'm teaching 205 after maybe 2 or 3 years ago gap, after 2 or 3 years gap. So I realized that probably you guys might have been exposed to the concept of refactoring. Typically, we don't do that, but maybe I believe your batch might have seen the refactoring concept, right?
Yes. A bit. Just
A bit,
small
a
part.
bit.
Yeah.
Yes. So what comes to your mind? Can you guys share your understanding of what's a refactoring?
What I know about refactoring, like if I do a method, okay, and do it for the first time, and I do the concept of it, okay, and it's work fine, okay, then I do refactoring to make it more simple and to make it not complex and make it readable by humans.
Correct, correct. Anybody else would like to comment? Their understanding of the refactoring?
Maybe make the design of the code much better than it was.
Correct, correct. Anybody else would like to share his
Doctor,
understanding? Yes, go ahead.
I think when coding, um, we continuously reevaluate our design decisions, and if we find conflict with any design principle or architectural style, we use refactoring to fix this issue.
Interesting. Yep. One last comment. Anybody else who would like to share his understanding on the refactoring? Okay, so I believe everybody, you guys kind of, I think you guys got the basic ideas, correct. But now what I will do is I'll try to make it more formal, and I'll try to define it more formally. Of course, we will not be able to cover this today, but we'll just start and we'll just look at some basic definitions today, right? So again, refactoring something which has been there for last about 20-21 years, and first time it was introduced by Martin Flower way back in 1999, and ever since, a lot of work has been done on understanding the refactoring and basically, coming up with solutions, and some of them in the beginning were manual. Now a lot of people are trying to focus on making it automated using, machine learning techniques and so on and so forth. So this is
Doctor, we can't hear you.
Can you guys hear me now?
Yes, we can.
Yes, we can hear you.
Okay, something happened here with my mic. Okay, so I was saying basically, Martin Flower is the first one who introduced these ones, and it's something which is catching up over the years, and something which is used in the market for achieving the aim of the refactoring. Now, the ultimate objective, if I have to put it, objective of refactoring is to basically improve the existing design using refactoring. So basically, we're always looking, as something like, hopefully we were hoping that somehow, we'll have a button on a keyboard where we will just say refactor, press that button, and everything will be refactored for us. It will just improve the existing design for us. Of course, this is the aim, and then people are trying to achieve that aim using, different techniques and machine learning techniques and many things. But we haven't reached that stage yet. But a lot of IDEs nowadays have refactoring inbuilt in them, like Eclipse and all of them have refactoring inbuilt in them. And they are, we're getting there where you can start doing refactoring more automatically. But we'll talk about this later. We'll talk about, what are the things we try to refactor and how we refactor. But let's first of all try to understand what is refactoring, right? And then we'll look at, why we do refactoring later. And then we'll look at the examples of refactoring. We'll look at some smells between classes. and we'll look for some obstacles to refactoring as well. Of course, not today. Today we'll be only focusing on what is refactoring. So let me share you with some definitions, and we'll talk about this as a class together then. So, for example, Rob way back in 1998, he said what? He said that a behavior preserving code source to source program transformation. So he came up with this explanation. He said that it's a behavior preserving source to source code program transformation. Ken back in 1999. Again, if you notice, this is a time where the refactoring was being coined and people were understanding that this needs to be done. And they said that a change to system that leaves its behavior unchanged but enhances some of its non-functional qualities like flexibility, understandability, and the list goes on, right? And then Wakes said that refactoring is the art of improving the design of existing code, and refactoring provides us way to recognize problematic code and give us recipes for improving it. All right. So he said that it's all about improving the design of the existing code, help us understand or look for problematic code, and then we go on and improve it. Probably the clear definition, and probably that's why it's a more popular definition, is by Martin Flower, none other than Martin Flower, who is like a godfather of this refactoring concept. He says that the process of changing a software system in such a way that it does not alter the external behavior of the code, yet it improves its internal structure. Right? So he says that refactoring is all about not altering the behavior of the code, but rather than restructuring its internal structure. Now, can you pick up, based on these four definitions, can you pick up a pattern here?
The behavior or the functionality of the code stays the same.
Exactly. So the behavior, everybody's saying, preserve the behavior. Don't change the behavior. He doesn't really, Wakes doesn't say at all about this, but but Martin clearly says, don't alter the behavior of the code. So refactoring is very important, is key here. Key to refactoring is you should not be altering or changing the behavior of the code. All you are allowed to do is change or improve the internal structure of your code. Now this leads me to a question. If I have a program, a piece of code, a method, and it doesn't compile, will I be doing refactoring to fix it?
You would make a maintenance to it.
Or debugging, right?
Debugging, yes.
Yes, we'll be doing debugging to fix it. For you to do refactoring, what's the first prerequisite?
Don't change, only enhance. Don't change the external behavior. Like if you have a function to count from 1 to 10, and it's go with a certain algorithm, don't change its original functionality. Only just make it faster, maybe.
Anybody else?
I think the code has to work.
Code has to work. Yes. Exactly. So code has to compile for us to be doing refactoring. This is the first prerequisite. The code has to compile. If it doesn't compile, then I'm not doing refactoring to fix it. I'm doing debugging to fix it. Okay. And once I have the code compiled, then I'll try to make sure that I don't change the behavior. Now, the example one of our students just said that if it gives you an output of, for example, sorted out, sort something, right? The key point here to understand is that by external behavior that the array should be sorted. Now we can change it because we are allowed to change the internal structure. This means we can change the algorithms and everything as long as the output is not changed. Okay. This is the idea of refactoring. But for us to do refactoring, code has to compile. Now, how we do achieve this? So this is the most important thing for us in this whole refactoring concept. And this is, if you understand this concept, rest is just technical details about it. That when we change the internal structure, we should not make any change to the code. Now, how we make sure that this is happening? How we make sure, how we guarantee that this is happening? That I'm changing the internal structure, but I'm not changing the behavior. Testing, absolutely. You know, testing is a very obvious way of doing it, and how we really do it. Basically, test the original system, look at its external expected outputs, actual outputs, change it, refactor it, rerun those test cases, make sure that things have not changed. Right? Of course, we have certain formal techniques as well. We'll talk about this later. I think we're running out of time here, so maybe I'll use this as a stopping point, and then we'll use this as a starting point as well. Okay, so today's lecture, I'll use this as a stopping point. Maybe I'll just stop it here. I'll use those comments later, inshallah. So we'll stop it here. We'll come back to this, inshallah, on Sunday, inshallah, after the weekend. Okay, so let me stop the recording, take the attendance, and